So now we got our results through hand calculations where we got a total inductance of 1.19 millihenries and a total capacitance of 3.32. So multiply the capacitance by 2 because they're in series and we want 2C there and 2C there. So we got approximately 6 nanofarads. In fact, a preferred value would be 6.7. Is what we would predict with hand calculations. Okay, the software that you're going to use to design your filters and get a simulated bode plot, the plot we saw earlier with the roll off, and be able to find out where the design cutoff frequency is, or the simulated cutoff frequency is, and use this program. This is freely available from Tunny Software, so you can download a copy and use it. So you could do this work away from this classroom if you so wished. You can save your designs if you want to. Start a new design. Okay, we're looking at a high-pass filter, capacitor input high-pass filter. We're doing constant K for our design type of filter, and we need to leave the order as 3. That's just about those 3 components. You can extend the filter design by adding more stages too. And the other thing we need to know is what's the input termination, 600 ohms. So there are the 3 things that we need to do. If you are doing a low pass, you will be doing a capacitor input low pass, I believe. If you get the wrong one, you can always change. You will remember we're looking for 1 inductor. Right. From that, if you click schematic, it's asking, there's one more box I should have filled in, bandwidth. So that's what the cutoff frequency is. We want 40,000 hertz. Continue. So there is our perfect design at this stage. Okay, and that matches what we got by hand. 6,631 picofarads. Remember what we got to do with that. We got to move this decimal place back over this way to make it 6.6 nano. So essentially, okay, same on that side, and a 1.19 millihenry inductor in the middle. Yep, all happy with that. Now, go to tab, and here's where we're going to specify what range of frequencies we're going to look at for our plot. Starting frequency, we'll do 10 hertz, and if we go up to 1 megahertz, we'll remember our cutoff frequency is only 40k. Let's go 10 meg. Span that we're going to do. Don't need to touch anything. We can plot that situation. So what you'll notice is you've got the transmission in dB here. We go from 0 at the top down to negative, and then the blue line here, over here in the passband. If you click on the blue line, you can have a look, and the 2 we're interested in are the frequency and the transmission, the decibels. So at that point we're -4. So up in here in the passband, we got perfect transmission, no attenuation at all. No, practically that's never going to be achievable. And then we can look here for our -3 dB transmission point, roughly around, that says 39k. Okay, if you actually work out what the 10 times the log of 0.5 is, it's not exactly 3, but it's close enough for it not to matter. Okay, so you can look at it like that. The other thing is